Welcome everyone. Thank you for joining us. I, Dr. Akhilesh Atoria, on the behalf of School of IT, AURO University, would like to welcome you all for the webinar on DevOps, that is Development and Operation, focusing on Ops, that is Operation part. Today we have an eminent speaker with us, Mr. Joginder Singh. He is currently working as Senior Technical Architect, HCL Technologies, Sweden. He also worked with HCL Technology, Great Britain. He is having more than 10 years of experience in IT industry. He has done CISSP, RHCA, MCSE Cloud, AWS Solution Architect, International Certification. As a part of large design team, he has been involved in participating in large projects of migration and integration to cloud service and securing and maintaining compliance on both on-prem and cloud infrastructure, that is AWS, Azure, Hyper-V, RHEF, OpenStack, and VMware. He also created, implemented strategies and solution in respect of GDPR directives and compliance requirement. So I welcome you all again, sir, on the behalf of AURO University and School of IT. So now, without further ado, we'll turn the time over to Mr. Joginder Singh. Over to you, sir.
Thank you, sir, for such an introduction. A warm welcome, and thanks everyone for joining and giving me time to speak about the topic. When it comes to topic, we are very much in discussion about other things within DevOps, but today's focus would be on the some topics where we come talk about the products, tools, and strategies among the industry when it comes to DevOps, basically. So you already introduced me, that's me. Now moving, what's DevOps? So every vendor sort of have their own definition, what is the DevOps in their terminology, and every vendor has given their tool sets. So we are going to talk about those tool sets, the modern ways of achieving the faster to market development, including their requirements and infrastructure. So I belong to the infrastructure domain, so my focus is more of a from the operation point of view to maintaining those infrastructure being used and provided by the DevOps journey as such. If we move further, we have different main four players which I have chosen to talk about. One is IBM, one is Google, one is AWS and Azure. So these are the cloud player as such. You can use DevOps journey in your on-prem so-called, or in a hybrid model as well. So we can talk about all four players or main players around the DevOps journey. When we talk about the difference in the culture, what is DevOps and what was the traditional IT, the approach where we delivered from DevOps is isolate, you can say, removing the gaps between the two different teams, development and the operations. So that's why the word was given as DevOps, development and operation in single view point of view. So operation part is also established well in advance from every single stage, avoiding delays in the requirements or understanding of the product itself, what development team is doing. So everything goes in hand in hand sort of. So there are less gaps when it comes to the actual production and deployment. And when we talk about DevOps, it has given, based on the agile methodology and everything, it has given more speed to the development and release cycle, so as the monitoring and planning cycle. So this might be very, you can say, not the complete picture because there are many players and many tools, but the whole cycle, what we call it as DevOps loop, is mostly the same. It is the difference only of the tool set or the tool chain, what you want to use or what you are using in your establishment and the environment. So this is the main fundamental tool chain. Where we talk about planning and building, the work begins with the planning and defining for the requirements, the metering and security. Next step is design software and its configuration, building and coding sort of. You can see the tool chain which is involved in this phase is mostly Confluence, Git, Jira, Maven. So these are the tool set where we use. Next comes the verification and testing. At this stage, code quality is being checked. Does the code conform to the design? Does it work as needed? And can it be maintained? Or the focus for this basically the stage of loop. There are testing for performing security and configuration checks as well. Later comes the actual release and deployment, which we will be focusing on today. After the work has been designed, built, and tested, the work becomes a release. That's why we call it as packaged for deployment or deploying. Similarly to creating a play for the threader, this phase is also called as staging, because we are going in released phased manner and pre-production, and the release will have a schedule not unlike a theoretical production, with the contingencies for fallbacks and recovery, like a stand-in actor for lead actors and so on. So, and the continuous integration is the important term here which has been given. It is like an choreographer for a theoretical show, with all the participants and elements of production moving simultaneously and smoothly. This approach is the heart of DevOps cycle for software development, basically. When it comes to further changes and further stages, configuration and operation is what we talk about. This stage is more operation oriented, basically the ops part. After the release has been successfully deployed, the work is about configuration and infrastructure provisioning for that deployment what the developer has developed so far. Obviously, as the requirements was there and the production team was always involved in the stage one as well, so they already knew that what need to be delivered and provisioned and maintained, sort of. But it's a big cycle of deployment and big infrastructures to maintain and so on. That's why this stage is more explicitly been specified, where we use tools like Chef, Puppet, Ansible, Terraform, Kubernetes, and OpenShift for driving these things. And obviously the vendor-specific cloud terminologies what they have given for achieving the same goals. And the most crucial part becomes the monitoring part, which is a kind of feedback loop back to the developer and back to the infrastructure guys. At this stage, a release has been deployed already and has been configured and for operation. The work is focused on watching and measuring how the solution is working, monitoring to the end user issues, and experience and IT infrastructure performance. So this is the key to understand where we are going wrong, whether the infrastructure is wrong, where the code changes are required, fine tuning is required at what level, whether it is on the you can say code quality or infrastructure capacity planning and so on. So here I will start my you can say main topic, sort of, with the focus on DevOps. Beyond establishing a DevOps culture, teams being using DevOps to manage and implement the certain practices throughout the application lifecycle. So the main objective of DevOps is to accelerate, automate, and improve the specific phases, other than spell several phases, helping teams create seamless process and so on. So the key terminology which has been given, or you can say being used, is infrastructure as a code. So with the involvement of clouds, the infrastructure is no more an abstract layer. All the components are programmable and can be managed as a configuration and code. So there are various ways to manage and the same. They are generic and hybrid tooling, and some are very vendor specific tool sets. So as I mentioned, Terraform is one of the main common platform where you can use it to manage any cloud environment and even the on-prem components of it. For an example, Azure use ARM templates to manage the infrastructure. CloudFormation is the name given for the AWS product which manages the infrastructure as a code, whereas the Google has given the deployment manager for the approach what they are using in their infrastructure as a code strategy. When it comes to IBM, it's having you can say dependency on on the generic ways of using it. So it's morely dependent on Terraform sort of. Now moving further, everyone is aware from the DevOps configuration management. So this is the heart and soul of what you call it as operations, the ops part. So we need both in control and use the version control for managing the configuration. As I said, with the introduction of cloud, everything is code. So code is used to be version control. So similarly, the infrastructure part, when it comes to infrastructure as a code, is also should be part of the version control, that what changes you have made and for which release and so on. So this is the most time-consuming part for operations. It is done once and maintained going forward approach for the infrastructure mostly. You can choose the tools of your choice like Puppet, Chef, Salt, Ansible for the configuration management. When it comes to Chef, it's been implemented by AWS as the name of ops work. That is the configuration manager which they want to, you can say, use as a vendor. When it comes to configuration management, the AWS also named as system manager. AWS system manager is another vendor specific solution for configuring the management and much more operations in AWS. Whereas they also have given another term, policy as code. So it is a AWS config is a fully managed service that provides you an AWS resource inventory, configuration history, and configuration change notifications also to enable security and governance. Configuring rules enables you to create rules that automatically checks the configuration of the resources and records them when there are changes to the infrastructure, so that you can later on understand when the infrastructure change happened, whether it was intentional from a governance point of view, for billing point of view, and so on, that who did the infrastructure changes at what level and so on. Moving further, as I said, the most important part is the monitoring, where you do nothing but just observe the systems. So collecting application performance and error logs is the most boring but important task, and it's mutual task for developer and to investigate the errors based on the codes or something when it comes to application error handling and so on, or a gap in the performance when it comes to the infrastructure itself. So ops obviously can only deal with the performance issues based on the infrastructure. So some people will still talk about, we are still talking about DevOps and we are focusing on ops because it has to be a single team sort of, but still expertise lies between different individuals within the teams as well, and DevOps is a team culture rather than a technical shift as such. A developer is more focused on the development part, and that's why you have the DevOps team together where they can focus on individual components and still think alike sort of. So obviously monitoring is the key for the DevOps journey. And when it comes to monitoring, governance is and security is most crucial as of today, because you might ship the best code, but if it is having some sort of security, then it's a problem. And with the security and the overall budgeting and sort of things, the governance comes into play. Moving further, let's talk about the common tool chain. So Ansible, Chef, Puppet, and Salt, they are the configuration management tools. Mostly Ansible is a kind of agentless approach, but it have a little bit dependency that it should be able to talk to the system via SSH, and obviously have some Python support because the Ansible is based on Python. The all four are sort of commercial products as well. And obviously when it comes to the open source world, the open source community, all have, or at least Ansible have the open source version of it where you can use it free of charge in your organization. With the enterprise products, you also have the support from the vendors. Ansible is given or maintained by Red Hat, so you subscribe for Red Hat subscription for the support for Ansible. Rest they have the individual organization to support for the other configuration tools which we use in the industry. Talking about the most known term, Kubernetes itself. So this is the way everyone has started moving towards the DevOps journey, and it will be incomplete itself to talk about the DevOps without talking about the container. So container is a similar the thing like VM, but they have relaxed isolation properties to the shared operating system among the applications. Therefore, the container are considered lightweight, similar to the VM. A container has its own file system, CPU, memory, processor space, security, networking, and everything. As they are decoupled from the underlying infrastructure, they are portable across the cloud or OS distributions as well. Kubernetes is obviously based upon the same container strategy. So Kubernetes is portable, extensible, open source platform for managing containerized workload and services. This facilitates both declarative configuration and automation. It has a large and rapidly growing ecosystem. Kubernetes services, supports and tools are widely available, you can say, from the supported organizations, even the vendors, and from the community standpoint. It's open source, so you can still use it as a community version and use it. The name Kubernetes itself is a Greek word which means helpsman or a pilot. Google actually open sourced the Kubernetes project in 2014. So Google is already using this Kubernetes platform for 15 years and so on. They do have Google has also extended their vendor support on your on-prem or local sort of version, what they call it as Google Kubernetes Engine on-prem. So you can use their services and integrate that platform, what you are running on your own data centers, to Google as a single pane of operations and so on. Moving further, they are vendor specific things which we can talk about, obviously. So this is the just AWS continuous integration and continuous delivery topics which are more towards the developer cycle itself, like AWS code pipeline, which is a pipeline strategy to integrate things from the development point of view till the production release point of view. Code build is the build and test engine for AWS, which you can leverage from AWS. Deployment automation is given the name as AWS Code Deploy. So it does deploy your code into AWS instances, on-prem servers, and you can use that feature as well in your development lifecycle. Later on comes a unified CI/CD project which is called Code Star. So it's have the whole integrated parts using the build, deploy, application, and everything in the single packaged sort of approach. There are other toolings, obviously, which is the ops part again. The container platform, what they call it as Elastic Container Services, ECS, whereas EC2 is their instance VM service. ECS is a highly scalable, high performance and container management service that supports Docker containers, and also you to easily run application on a managed cluster as well. Basically the backend for ECS is the EC2 again. They also have this new term being coined by them is the serverless as the name of Lambda. So you can run your code instance of running the code every time, like a container or a VM. You can put your code into Lambda functions, and when the events occur, so it's more of a event-driven execution of your code through the serverless approach. When it comes to the ops part of AWS, you have CloudWatch, which is more of a managed again service for your collecting the logs, metrics from the environments, whatever you are running, and even sending the alerts back to you when anything is happening in your alert sets, what you have configured for the alerting and so on. They do have something called AWS X-Ray, X-ray helps developers analyze and debug production distributed application, such as those built using a microservices architecture. With the X-ray, you can understand how your application and its underlying services are performing to identify and troubleshoot the root cause of performance issues and errors. They do have another component which is called Cloud Trail, which is more of a auditing tool or governance and security tool, who has access and what sort of. So this is the governance tool for AWS. You have the code commit, AWS code commit. It's a source control fully managed service by AWS, where you can put your code as a Git, what you could have done in your Git repository on the AWS platform. Moving further on the other vendor sort of. So AWS is the another key player. Azure is the another key player when it comes to market, the cloud market. Azure is given by Microsoft, backed up by their expertise and so on. So the whole tool chain is more focused from a Microsoft standpoint of view. So we must have, and they have, you can say, redefine these terms again to their deliverables like plan, deploy, deliver, and operate. When it comes to plan, they are talking about tools like Azure Board, GitHub, Power BI. When it comes to develop cycle from their point of view, they have the unknown tool Visual Studio. They have the lighter version of it, Visual Studio Code. Obviously, you have GitHub to version control or source repository of your code. They have Azure Pipeline. They have GitHub Actions. They rely on Jenkins as well, and they are, you can say, offering the developers something called Azure Dev Tool Dev Test Labs, where you can use your test environments from Azure for your application perspective. When it comes to delivery, they have this ARM sort of Azure Resource Manager. They also support the common tool set, which is Terraforms to deliver and create the infrastructures. They have these Azure pipelines and then Jenkins again to deliver the things on the Azure platform. When it comes to the key part, the operation part again, so they give you Azure Monitor, Azure Automation, and they also support Ansible and Chef, or even Puppet for your configuration management and so on. They have something called Azure Blueprints, which is close to Chef Automate approach, where you bundle everything from a environment point of view. So it's no more a single sort of infrastructure as a code or an application development cycle, but the whole bunch of complete landscape. What I mean, from organization to organization. So if you have multiple organizations as a requirement to be delivered, you can use your Azure Blueprints, which combines the whole stack from top to bottom sort of. So that's the approach from operate point of view from Azure platform. Moving to Google, which is the you can say initiator for Kubernetes and so on. So they have their own container products or solutions, which is Google Kubernetes Engine, which is a fully managed Kubernetes engine from their end point of view. We have container registry, which is a registry where you store your images basically. So whatever you are coding, you end up creating images out of it, and then you can leverage container registry as part of the Google toolset. The container registry is not only for Google, but for every DevOps journey. So whatever you produce, you try to create an image out of it, and the image is obviously stored in the registry when it comes to DevOps or the container platform itself. So not only Google, but Azure, AWS, IBM, or any other cloud platform is giving you the container registry for storing images. Container security have the different approach from different vendor point of view, that what tools that they use in the backend. So Google have that product called Container Security itself, which scans your images for the lifecycle of the image itself. Then you have cloud build approach, where you can use build as we have the other products in AWS and Azure for the build cycle, the build phase of the DevOps journey. So you can use cloud build, which can import your source code to the cloud storage, use cloud source repository, GitHub or Git bucket as well for the source of cloud build. When it comes to a repository point of view, you can still use internal version control system, which is given by Google again, which is called Cloud Store Repository as compared to your Git or something. So those are the tool sets from Google. Moving on to your on-prem, when we talk about the player as such, sort of. So I've just chosen one platform when it comes to open on-prem, which is OpenShift. There are other players like Cloud Foundry, Pivotal, Mesos OS, and so on. So they are the different flavors for deploying containers on-prem as well. Whereas Red Hat is backing up the OpenShift. So OKD is the open source version of OpenShift. The later version is called OpenShift 4, and this is more of a depiction from an OpenShift 4 standpoint of view, because they have integrated the whole stack in single approach. Whether you are running on public cloud, private cloud, or virtual or physical, you end up having Core OS as the heart of OpenShift. Obviously, the OpenShift is built upon the Kubernetes itself, but it's not just the Kubernetes, because in the Kubernetes you have just the facility to orchestrate your container landscape. But with the OpenShift, you have more tooling set and support from the OpenShift, Red Hat as a vendor, which includes cluster services, application services, service mesh, and developer services like DevTools. They have their own open source versions of tool sets which they support on platform of OpenShift. So that would be all from my end for the day. Thank you all. Be safe, keep learning. Over to you, sir.
Okay.
Yes, we have a question. So you can see over there where we use DevOps. Basically, so this is the question came from the Nikhil.
Basically, the approach when we talk about DevOps, so now we can talk about on a very generic way. So today or earlier, we were talking about the monolithic application, big applications, and so on. So everyone is trying to bifurcate or dissect those big application monolithics to microservices. So first important part to understand DevOps is that you try to dissect your bigger application which are hard to maintain to smaller chunks of microservices. And when you talk about later stage, everyone is talking about REST API. So when we talk about microservices, you try to create a coherent and cohesive system, but maintainable system. So every microservices have its own individual functionality. For an example, SAP is a bigger component, ERP is a bigger component, CRM is a bigger component, but within the DevOps cycle or DevOps journey microservices world, you try to dissect them into small pieces like billing. Within billing also you might have internal billing, external billing, different aspect of that billing as well into microservices. What it does is a single container holds your one department billing process. If you want to update that process only, you just update that particular container. So instead of restarting the whole development and life cycle of the whole complete project or complete application platform or a software, you just you can say update or patch that particular container. You talk about just doing testing around it, and you are ready to market again very quickly. With the test you can perform on a small code or a small amount of piece of code basically. When if it would have been a bigger application, you would have end up testing for months and so on. So DevOps give you the opportunity to test very quickly, deploy very quickly, and very frequently as well. And the approach for DevOps is multiple containers of the same services to increase to meet the demand or meet the scalability. Obviously, it's more of a you can say designed to fail sort of approach when it comes to DevOps or container world, that even if your container fails, your services should continue because there are other containers of the same nature serving the same purpose, and you can quickly respin them if there is a demand or a failure.
And one more question, Mr. Joginder. Should I learn all cloud solution or one is enough? I don't think so. It's related to this.
I can talk about from that perspective. At the end, if you are a developer and you, I would go on the presentation point of view in the first page itself, where we talk about the dev loop. Give me a couple of seconds. So, yes, this one. So if you talk about this one, if you are a developer and you just want to use your skills from a development point of view, you can use any cloud provider because they just differ in the terminology, as I said, because container registry would be same everywhere, and every cloud vendor supports the what you call it as Kubernetes engine or the container platform. So at the end, you ship a container image, and any cloud provider or any you can run with any cloud provider as such with that specific image. So it's a image is cloud independent, so you don't have to barge yourself with the different terminology and different vendors. Basically, you will end up using either of them because of the you can say enterprise strategy at your organization level, because hybrid model is still there, on-prem and cloud is integrated, but limited to certain vendors. You don't find a single organization using all the cloud providers, because the cloud provider which I have named, they are just 4, and there are many more in the market which you can use for your cloud journey.
We have 2 questions, Mr. Joginder, but it's looking similar. The question is basically how DevOps different from Agile methodology, and one more question is it similar to Agile methodology or not? And if not, how is it different from it? It's similar. Both are similar questions.
It is same in one nature, because Agile is the, you can say, way, because DevOps was there. And people have started thinking that what should we do. So Agile talks about very rapid development and so on. So if you have your monolithic application, you will not be in a Agile model at all. So DevOps is the way for achieving the Agile model basically. So they are one on the same. So Agile is more of a project management terminology, I would say, that your development cycle should be Agile and so on. And where a technical perspective, you talk about DevOps, that we need to go microservices, whether it's REST API based or not, but mostly small chunk of code running in a container and reproducible every time, scalable every time, tested frequently and so on. So they are one and the same thing, supporting each other sort of.
One and the last question: where can you use DevOps in the industry, or in a real life? I don't know.
If you are a developer, or if you are a beginner, because I know from we are talking about the people who are from the colleges and universities. So if you are getting into the industry and you are just learning, for an example, I will take Java as a language for your development, and if you are a developer, so either you have already came across these tools. If not, the first thing you will end up in the organization will be using the left part of the cycle, which is the dev cycle, I will call it as the code, build and test. Obviously planning is the something project management and project managers are doing along with the different teams, different player within the team itself. So when you try to develop a new product, or you are within the existing team, you end up as a developer using either maybe Git, maybe Confluence, Jira for tracking and so on, and Maven and so on for your build process. And obviously JMeter is something you use for testing. Jenkins is your pipeline tool. So you end up using all these tools. So actually you are part of DevOps already. So either you are already aware of these tools or you have to learn these tools when it comes to development. When it comes to the .NET developer, as I said, Azure is have its own tool chain. So you have already been using Visual Studio. So within Visual Studio, you have many new components being introduced called Team Server, Azure Pipelines, Azure DevOps, Azure Dashboard. So those are the cloud specific terminologies given to the DevOps journey from Microsoft. And within your on-prem also, you can use those Visual Studio components and directly create container images, deploy them over Kubernetes on-prem or on the Azure services for container.
Since this is the last question, thank you so much, Joginder sir, for such a wonderful and knowledgeable session. Now, I would like to call the Dr. Sunil Kumar sir to give a vote of thanks.
Okay. Yes, I have one question regarding DevOps. What is the future scope of DevOps for our students and participants, as it is emerging IT technology?
I would say that in the long run, I belong to the ops, but in the long run, it's more of a developer journey itself, because as I said, in the cloud journey, everything is getting automated. So the control is more shifting towards the developer. But when it shifts towards developer, they need to, you can say, get their hands dirty on the infrastructure components as well, that how the underlying hardware or underlying infrastructure is working. So from a DevOps point of view and future point of view, DevOps is the whatever development you are doing in the future, it will be based on Agile. And when you talk about Agile, it will be based on DevOps, because everyone want to ship quickly, easily, and it should be maintainable and scalable sort of approach. So if you still deploy big application in the VM, it might not be the future for going forward.
Okay, thank you. Yeah, dear participants, thank you for attending the webinar on DevOps. We hope that you find the webinar informative and worthwhile. Mr. Joginder did an outstanding job of sharing his expertise with you. On behalf of AURO University, thank you, Mr. Joginder, for speaking to our students and other participants. We are grateful for the time and effort you took to share your thoughts and experience with all of us. Thank you for your contribution. Please accept our sincere appreciation for the outstanding presentation. Thank you.
Thank you all for listening. Have a nice day.
Thank you, man. Thank you, Mr. Joginder. Thank you. Thank you so much.
Thank you.